Okay, the dot product of two vectors. How did we define it? Okay, this is number 3. So, this is A dot B is this is AX, BX plus AY, BY. Now, if there's a third component, Z, then we can just add AZ, BZ in 3 dimensions, no? Or we have an alternative definition here. We have A dot B times the magnitude of B times cosine of the angle between them. Well, suppose you have vector A here and you have vector B here. This one here, this angle of separation nila is what we call theta AB. Now, if the vector is given in Cartesian form or rectangular coordinate system, then this definition is much easier to use. This is quite difficult for that. Why? Because in order to use this, if you have a Cartesian vector, first you need to calculate for the magnitude of A, and then again for the magnitude of B by using the Katong formula for the magnitude. Okay? And then after that, this is the more difficult one. The most difficult part actually in using this one is finding this theta AB here. No? Well, you can not that it's impossible to find it, but it's quite a work to do it, no? You have to do some trigonometry dire. So if this is difficult to use, then why am I putting this definition? Okay? Well, that's because in the next vector in the next way of writing a vector, we're going to write it in terms of its magnitude. Remember that the Cartesian vector is not written, it's not given in terms of magnitude, but in terms of the in terms of the instruction, no? In terms of the x component and the y component. Remember that I told you that a vector is actually an instruction. It's not only an allocation, it's also an instruction. What's the instruction? AX, no? AX will tell you how many steps you're going to walk with x on the x direction, either left to the right, depending on positive or negative. AY, on the other hand, is actually on the vertical direction. Okay, we'll have some remarks on this. What's the last remark that we used? No, number 6, remark 6. Remark 6. So, this is now remark 7. Now, what's the value of cosine? No? Cosine theta is, we know that cosine, okay, so theta AB. We know that cosine of an angle theta, okay, for any theta, this will be from 1, just take the absolute value, to 0. Or if you don't take the absolute value, it's from -1 to 1. Okay? So, the highest possible, okay, the largest possible value of cosine is 1. And the smallest possible is 0. That's for the absolute value. Now, okay. Meaning that the A dot B is maximum, by this definition, we can actually look at the maximum value. A dot B is maximum when? A dot B is maximum when? When cosine of theta AB, when cosine of theta is 1, right? So when does cosine of theta happen to be 1? No, when theta is what? Theta is 0, right? Okay? Cosine of 0 is 1. So sa ato pa, A dot B is maximum when the two vectors are parallel. Okay, or even anti-parallel. It's actually -1. It's maximum, no, value. Parallel or anti-parallel. Just we call these two vectors parallel or anti-parallel as parallel for now, no? So here we can have remark 7. A dot B is maximum when theta AB equals 0. Because cosine of 0 is just 1. Meaning the two vectors are parallel. This implies that A is parallel to B. This is the notation. A is parallel to B. Okay? And part of this is A dot B is minimum. What's the minimum value of A dot B? That would be equal to 0, right? When theta AB equals 90 degrees or pi over 2. So this implies that the minimum value occurs, the 0 occurs, is that when A is perpendicular to B. Now, we can actually use this very, let's call this some remark 8, no? To separate this one. We can actually use remark 8 to show that two vectors are perpendicular to with each other. Nakuha? If the vectors are written in Cartesian form, then it's not actually that easy to see that two vectors are perpendicular. Now, for example, okay, example, show that the vectors, 2, 3, and -3, 2 are perpendicular to each other. Okay, so how do we solve this? All we have to do is, let's take this as A and this is B, no? So A dot B now, or we'll just use this one, sato pa, 2, 3, dot -3, 2 is equal to what? This is 2 times -3 plus 3 times 2. And you see that this is -6 plus 6 and this is 0. Okay, so they are actually, we can now conclude that these two vectors are perpendicular. Okay? I'll just introduce a new way of writing vectors. And that is using the, well, I don't know what's the name of this, but I call this the modified polar vector. Because in general, a polar coordinate system is given by the polar coordinate system. Polar coordinate system is actually this. Now you have for any vector here, you have for any point here, you can take this coordinates as what? For any coordinate here, this point is some distance r away, and from the positive x-axis, it has rotated by a certain angle, theta. So here, this is r and this is theta. We can label this as r, theta. That would be the polar coordinate system. But the coordinate system I'm going to introduce, and this is used in many books, no, in introductory, at least in introductory. Of course, in the advanced level, you don't use it anymore. But whenever whenever you teach introductory vector analysis, we use the I'll call this the modified. I personally call this the modified polar coordinate system, or maybe I can just use modified or loose coordinate system. Now this is coordinate system. This is not in the books, this is not called this way. It's just called, it's just a default way of writing a vector, no? But I call this a modified polar because in the standard polar, the theta is always evaluated here, no? Or you can evaluate theta on the counterclockwise direction, no? So, or you can actually define an angle like this but write it in a negative angle, no? For example, in polar coordinate system, let's say you have 3 meters, this is pi, 3 meters, 4 pi over 3. Well, what is this vector? Asan siyang vector? That's actually 3 meters from the ano, and then the angle is 4 pi over 3. That's 4/3 pi. That's pi plus pi over 3, no? So, dire. So, meaning, you have this point, that point there, and this is 3 units away. Kana siya. That's 3 meter, 4 pi over 3. Okay? We can label that as ano. Or you can actually call this as, this is also equal to 3 meters negative 2 pi over 3. This is negative 2 pi over 3 here. Okay? This rotation is negative. No? Or actually, I can just say 3 meters in terms of degrees. This is what? 4 pi over 3 is 180 plus 60. That's 240, right? 240 degrees, or which is also equal to what? 3 meters negative what? Negative 90 plus 30. This is negative 120 degrees. Notice that if you add these two, absolute value, you get 360, right? Now, you now understand what's a standard polar vector. Because I want you to relate this to the modified polar vector nga gina-introduce sa libro. That's actually being used in many books. Okay? So, what is this modified polar? It's actually also a polar. It's given in terms of R. Okay? A polar vector is a modified vector or Nuss vector. Let's just call this a Nuss vector, no? Okay? Let A be a Nuss vector. So that we can write A in terms of what? The magnitude of A and direction here. Okay? The magnitude of A and some directionality. Let's say either of this. No, anyway, I'll just put some direction here. Or direction. And kaning direction karon ang kalahian. Because you also write a polar vector like this, but the direction is actually given in terms of the rotation, no, of the angle. That is the direction in the standard polar. This is the rotation is coming from the positive x-axis. This is also a rotation, but the rotation in the Nuss coordinate system is actually it could start anywhere in the 4 axis, either on the it could start in the positive x or the positive y, the negative x or the negative y. Usay meaning nako ani. Like for example, you have this vector here. Let's say this is A. Now, let's say this is theta A. Then I would write this A as, I can write now A as, okay? I could write this A now as what? The magnitude of A, theta A, north of east. Because this is, okay, by the way, this is north, east, west, south. That's why, by the way, that's why I call this the Nuss coordinate system. North, east, west, south. Okay? That's why I call it the Nuss coordinate system. North, east, west, and south. So, the rotation is coming from the east towards the north. That's north of east. Or maybe we can just call it NE, no? Northeast, no? Or north of east. Now, theta A, north of east. Here, in the news coordinate system, theta could not be more than 90 degrees, right? Unlike sa polar that it could go around up to 360. No? But in the modified polar, the news coordinate system, theta is between 0 to 90. Of course, because you are referring ano. Now, I can also write this as A, what? Kani siya, oh, let's call this theta A prime, no? Or theta A, ano lang, no? Theta A bar. Theta A bar, east of north. We can call it. Now, this is quite a problem. Why? Even kung makita ninyo ni siya dire. It seems that it's not actually, there are many ways, no, to name a vector in the polar coordinates. This same point is actually equal to what? Is also equal to what? 3 meters 4 pi over 3 plus 2 pi, one rotation. And this will give you the same, ano, and this is a different number, right? In fact, this is what? This is 10 over 3, tama? So, this is actually what? 4 over 3 plus 6 over 3, that's 10 over 3 pi. This is also equal to that. And this is also equal to 3 meters what? Plus another 2 pi, which is 16 pi over 3. So, it's infinitely many ways to do this in the polar standard. No? But of course, who would name a vector this way? What I'm saying is that in the standard polar, no, because of the, this will refer to to the same point. Pero naay kalahian. Why? The difference is that this has rotated only kaisa dire. While this one, kanisya, this has rotated niya, ni ana pa siya, aya siya ni ano dira, no? So there's rotation. How about this? There's 2 rotations before settling on this point. But of course, that would refer to the same point. Kanisya, there are 2 ways to write it. No? So it's not unique. Unlike the Cartesian vector, that it's unique. Right? Nakuha ninyo? Mo'y kalahian niya. So the Cartesian vector is actually a unique way of writing that one. So, anyway. So, for example, another vector, let's say we have this vector B. No, we have that vector B. And let's define this as theta B. So, theta B would be what? B now would be equal, given by, in terms of the magnitude of B, what? Theta B, what's the direction? West of south, no? Because the rotation is from south to west. So, meaning this is west of south. No? So, a concrete example for that is that we can actually sketch this vector. Let's say vector A is given by 2 meters 60 degrees north of west. And some vector B as 5 meters 20 degrees west or 60 degrees west of north. So, unsa ni siya? You have north, east, west, and south. So, here, 2 meters, 60 degrees north of west. So, say meaning, ani, you go from west to, the rotation is from west to north, right? That's north of west, northwest. So, from west, you point your direction to the west and then rotate by 60 degrees, right? So, ibig sabihin, naana siya diri, no? Mauni siya nga vector. and walk by 2 meters. So this is now vector A here. This is 60 degrees. How about B? This is 5 meters west of north. Ibig sabihin, that means that from north you go in the direction of to the west by 60 degrees. So north, rotate by 60 degrees to dire, but it's walk by 5 meters. It's quite long. It's quite longer, no? So this is vector B. No? So this sense of directionality is important. So by the way, so that not to confuse, we can actually have an agreement here, no? Agreement. For this course, we can have an agreement because I will name only the vector such that the rotation is from the x-axis. Okay? So that this is an agreement. We are going to name the vectors only such that the rotation is either of the positive, either of the two x-axis, the positive or the negative. That means that the direction that only we are going to use is what? From here, paana, meaning northeast, right? And then, paana, dito sa south, southeast, or northwest, and southwest, right? So this is the only direction that we're going to use, no? To simplify things, meaning that we have to force the vector to be the angle on this one. Because even if the vectors are given, even if the angle is given this way, in this, sa kaninga side, you can actually define this by just subtracting it by 90 degrees, right? In fact, you can, this is west-north. I can convert this into northwest direction by what? 90, this is still 5 meters, and then 60 minus, 90 minus 60, that would be 30 degrees northwest. Now, that they now have the same direction. Okay? So we can just use that one, no? So to avoid, not confusion, but to avoid a lot of, kuwan ba? So we can have this convention, no? Now, as I've said, in this type of vector, balik na dito sa ano, let's, okay, by the way, let's define the, let's, atong ikuha ng dot product, balik, no? The dot product, the modified form of the dot product is A, B, cosine of theta, AB, right? We can now use this, here, it's now difficult to use the first definition, AX, AY, AX, BY plus AY, AX, BX plus AY, BY. It will now be, if our vector is given like this, in this way, it's now difficult to use that definition. Why? Because we are no longer in the component form. No, we also call that the component form of the vector. Cartesian, we call that the component form of the vector. Okay, but it's not a formal name actually. But since we are now given in terms of magnitude and the angles can easily be calculated, we can now use this. Okay? So for example, if this is vector A and this is vector B, what is A dot B? What is A dot B? That would be magnitude of A times magnitude. This is already the magnitude of A, right? And this is the magnitude of B. So sa ato pa, this is 2 meters times 5 meters times cosine of the angle between them. What is the angle between them? Well, this is 60 degrees northwest and 30 degrees northwest. So, ibig sabihin, the difference is, kanisha, since this is 60, so this must be 30, right? And since this is 60 here, this one must be 30. So this one must be 30. So, okay, the angle between them is just 30. It's easy to calculate. So cosine of 30 degrees, which is what? This is 10 meters squared times cosine of 30 is what is the cosine of 30? This is square root of 3 times square root of 3 over 2, or this is what? 5 square root of 3 meters squared. No? 5 square root of 3 meters squared. What? Now notice that the dot product now has an area, has a unit of an area. What is that area? I asked that one last meeting, but wala na ako siya answer. We can actually we can make sense of that area. Okay? Oh, how do we make sense of that area? Now let's have this illustration. Suppose this is A and this is B. Notice that for simplicity atong ipataas si A and ano yun lang, A and then this is B. Okay, let's actually take the order of this one, no? This is A cosine theta AB times B, right? This is the same. Tama? Pero, I rearrange this to give a geometric meaning on this one. What is A cosine of theta? What is theta AB? This is theta AB, right? So, meaning, A cosine of theta AB is that length diri, no? Imagine a right triangle nga imagine this right triangle here. No? Imagine that right triangle here. This length is given by that. Right? That's A cosine theta AB. Tama? Kana siya. Times B, sa ato pa, that area is, kani siya karon, no? This one, ato na siyang i-project diri. No? Make as, kani. This is, let this length be this length here. No? And we now have a rectangular area. This area here is what we call A dot B. That area there. No? But we are not actually interested in this area. What we are interested is that A cosine theta AB, part of this product here, no? Imagine if what happens if B is a unit vector? Okay? What if B is equal to a unit vector B? So sa ato pa, the magnitude of B now, this implies that the magnitude of B is equal to 1. Right? So, the dot product A dot B hat is equal to what? The magnitude of A cosine theta AB times just 1. And it will give you this length. So this is what we are really interested in, the dot product. We call this the projection of A in the direction of B. If B is a unit vector, right? This is actually what happens if you have dot B there, di ba? What happens if you have the sun exactly such that ang sun rays is perpendicular to B? What would be the size of the shadow of A in the plane if B is a plane here or whatever? Kung sa ikuan niya, what would be the length of the shadow of A if the sun is if the sun's rays is perpendicular to B? Nakuha ninyo? So, that shadow is this one. Okay? A cosine theta AB. Now, to find that one, all we have to do is actually convert B to a unit vector, right? And we can now see that this is the projection of A onto B. We can also do the same vice versa with B onto A, right? So this is, we can call the dot product as A dot B. We can say that this is the projection of A onto B, or the projection of B onto A, onto the direction of A. But to fully do that, you can actually convert one to a unit vector, no? So nasabtan. So this is the geometric significance of the dot product. Nakuha ninyo? Aside from the fact that the dot product helps us to identify perpendicular vectors or to verify perpendicular vectors, it also gives us the notion of projection. Because it's important, in the component form ng good, we know that AX is automatically the projection of A onto the x-axis. Nakuha ninyo? That's automatically that. Tama? AX is the projection of A onto the x-axis. Okay, and AY is the projection of A onto the y-axis. And we are going to prove that later when we use this unit vectors I, J, K, that these are indeed, AX is indeed the projection of A onto the x, and the AY, the projection of A onto the y. Okay, nasabtan niyo? So, that is now the geometric meaning of the dot product. I'll define the special unit vectors, no? I'll define this definition. The special unit vectors in R3 or R2 or even R3. Okay? In R2 or R3. What's R2? That's XY. R3 is XY, Z. What? R2, the two-dimensional R2 is, okay, let's have this as R3 here. So R2 is, we only have I and J, no? This is 1, 0, and J hat is equal to 0, 1. Okay? In R3, this is I equals 1, 0, 0, J hat equals 0, 1, 0, and K hat is 0, 0, 1. By the way, what is the standard axis, no? You have this, imagine this pana, no? Positive Z, positive X, and positive Y. So this is positive X, positive Y, and positive Z. So sa ato pa, I is a unit vector. It's a unit vector. The length of this is clearly 1, right? This is I, this is J hat, and that is K hat. In this case, you have I hat and you have J hat. Okay? So, for example, in R2, technically, we can now write, okay? Okay, remarks. This is actually a theorem, no? Remarks 7, 8, 9. We can now write in R2, in R2. In fact, we can do this also in R3. Or R3 na lang siguro. In general, no? We can just omit the ano. Okay. So we can now write this vector as this. This is the standard in standard physics books, university physics books. You will see that a vector is written like this, no? Or pag two dimensions lang, AX plus AXI plus AYJ, no? But we can actually, I can prove this, no? By that definition. Okay? I can prove this by that definition. I'll show that if this will lead to this one, no? This was our definition of A, katong una-una, the default definition of A. This is not the default definition of A. This is a complex definition, not complex actually, but a more complicated definition of A than this. This is the simplest one. Nakuha? Now, I'd like to show that I can to prove this one, I'll go from this one to that one there. So I have to prove that this is indeed equal to that. Well, to start with, I have to form this equation here. What is that? This is ax times 1, 0, 0 plus ay times 0, 1, 0 plus az 0, 0, 1. Right? And this is just scalar multiplication. Tama? So this is ax and then 0. Ax times 0 is 0. So 0, 0 plus 0 ay 0. Plus, this is 0, 0 az. And so when you add this, well, you only add the x, y, and corresponding x, y, and z components. So you have now ax, ay, and az. So there you go. There's the proof there. Oh, that's the proof. Meaning this is not, in fact, this is quite a, it's not the default way of writing a vector. I mean, yeah, it's a default, but it's not the simplest way of writing a vector. Okay? So from now on, we now write a vector a Cartesian vector in terms of this. Right? In terms of the I, J, K coordinates, I, J, K unit vectors. Okay, by the way, to look tanawa, AX is actually the projection of X onto the onto I. What's the projection of, you have ane? Ako na to ha? For two vectors lang. This is A, and this is I hat. Right? AX, I would say, is the projection of A onto the direction of I. What is the direction of I? The direction of the positive x-axis. What's A dot I? A dot I is, okay, this is, by definition, A is given by this, sorry, kanilang sa tanong. A is given by this. So A dot, okay, I'll write this one. I write it here. A dot I hat is equal to what? This is, A is given by this, AX times 1 plus AY times 0 plus AZ times 0. These are all 0, so this is just AX. In fact, you can show that AY is equal to A dot J and AZ is equal to A dot K hat. So what I'm saying in this calculation is that AX, AY, AZ are indeed the projections of A onto the X, Y, and Z. And that, well, of course, that's how we define it, right? But by using I and J, we have retrieved that definition. I can now define the cross product in vector. Because last meeting, I was not able to define the cross product in vector form. I told you why, because we have not, the reason is that we have not yet used this notation here. Okay? Now, we can now have the cross product. Okay, this is number 4, no? This is the fourth one. This is the fourth because this is just continuation of the last meeting atong gikuan. The cross product, so we denote this A cross B, which produces another vector. Okay? A cross product produces another vector. Okay. This is the definition of that. A cross B is the definition, is defined as the determinant of the matrix formed by this AX, AY, AZ, BX, BY, and BZ. Okay, don't worry about this. This is just determinant, right? Determinant is, you calculate it by, first, let this to be the, kaninga ano. So, this is defined as I hat times, kani, okay, AY, BZ minus AZ, BY. minus, alternate ni siya, j hat times, wala na po ni, ax bz, az bx. ax bz minus az bx plus k hat times kx, okay, this is k hat, ax by. ax by minus ay bx. This is, now clearly this one is a vector. Why? This one is a scalar, right? So meaning this is a vector. This is another vector. If we call it C, nakuha? If we call it C, then this is Cx. Nakuha? This is the x component of the third vector. The cross product of two vectors, okay. I'll put that as a remark. Remark 10 na to, no? The cross product of two vectors produces another vector. This is contrary to the dot product. The dot product produces a scalar, right? The cross product produces another a vector. Okay? And this vector, if we call this vector C, clearly this is a vector, right? Because you have, this is a scalar, this is a scalar, this is a scalar, this is a vector. So, so sa ato pa, this is a vector minus a vector plus a vector. Sabtan? Okay? So this is Cx, and this one here is, this is negative here. So sa ato pa, this whole thing here is minus Cy, and this whole thing here is Cz, the z component of the third vector. Okay? Now let's interpret this vector. Okay? I will, okay, I'll give it to you as a something to solve on your own. That I'll put another remark here. Remark 11. So I'll use C. If A equals A cross B equals C, then C is perpendicular to A and B. C is perpendicular to both A and B. So that means if you have a vector that only lies on this board here, the vector must be kani, no? Either direct pointing or on that direction. By the way, we can also conclude from this definition here, if you reverse this, what's B cross A? B cross A is actually, B cross A is, ato pa ni sa ano, naadiri ang B, naadiri ang A. And you can now see that A, you can easily show that, okay? Also, A cross B, we have this property. I'll just add it here. Or, din lang siguro. Property niya. No, property. Actually, property na ni siya diri, no? This is 11. This is already a property of that. So, let's call this property I. Remark 11I and remark 11 double I or 2. A cross B equals negative B cross A. Okay? So, you can prove this one also. Well, for example, how do we prove this one? Well, all we have to do is, it says that this produces a perpendicular vector, di ba? Now, to prove, first prove that C is perpendicular to A, what do we use? Well, we use the definition of the dot product, tama? Okay? To prove that C is perpendicular to A, okay, to prove that this vector here, A cross B perpendicular to A, all we have to do is use the dot product. Sa itong dot product. Let's take a dot, okay, to prove this one, let's take A dot C. This is what? AX times, what is C? X. This is CX, right? So, AY BZ minus AZ BY plus AY times CY. This is negative CY, so atong i-reverse, no? Yan na nato siya. So this is times AZ BX minus AX BZ plus AZ times what? CZ, which is this AX BY minus AY BX. So this is AX AY BZ minus AX AZ BY plus AY AZ BX minus kani AX AY AX AY BZ, right? Tama? Lagi AX AY BZ. Okay? Dire plus AX AZ BY minus, this is minus, so minus AY AZ BX. Okay, di ba this is that negative? No? So this will cancel out, that will cancel, and this is clearly 0. Okay? Now it is left to you as an exercise that indeed B dot C is also 0. You prove this one, no? Okay? Okay, now I'll give you an exercise. Prove this one now. Okay? So do it. Show this one. Okay, so anyway. So so you have now shown that B dot C or C dot B is equal to 0. Okay? Okay? So we have proven that since A dot C equals 0 and B dot C equals 0, therefore, C is perpendicular to A and C is perpendicular to B. It produces a vector which is perpendicular to ano. And, okay, okay. I'll give what's the magnitude of C now? I'll add, this is the vector form. I can now add the scalar form of the cross product. I would say that C, I'm not going to prove this one here because the proof is quite tedious, no? And it's not basic. It's quite advanced. But, okay, what's the magnitude of C? The magnitude of C, if C is equal to cross A, okay, ano na lang. Okay, I'll put it in the third remark here. Okay? This is actually if A cross B equals C, then the magnitude of C is equal to the magnitude of A times the magnitude of B times sine of the angle between them. This is actually important. This is much more important than the magnitude of the dot product. Okay? This is much more important than the magnitude of the dot product. In fact, here I can define the magnitude of A cross B as what? The magnitude of A times the magnitude of B times sine of the angle between them. From here. So I'll put that as a remark. But, okay? Or, di na siguro ni siya remark, no? Let's just remove this one from the remarks. Okay? Just part of the definition there. This is the magnitude of the cross product. Now, let's interpret this magnitude. You have A, okay. You have vector A and you have vector B. This is A. Okay, ato ni siyang i-ano, let's take this again as the magnitude of A sine theta. This is, by the way, sine theta AB, right? This is theta AB here, that angle. So this is, I'll write this one like this, times the magnitude of B, right? But what is this? This is, imagine again a right triangle dire, right? This length here is what? That length here is this. Okay? So sa ato pa, this is in fact the area of the quadrilateral. Right? This area of the quadrilateral form A cross B. The magnitude of the cross product gives you the area, kani nga area, no? The area of this parallelogram. That area, this area of the parallelogram is in fact A cross B. So, if this is, imagine A and B lying on the board. So, A cross B is somewhere, diri or dito. In fact, actually, padulong dito, no? Ang A cross B. It's the right-hand rule. A cross B is kani. So, meaning, since our A is here, okay, I'll just replace this. Okay. Nato namang nakuan ba? A cross B. Okay. So, sa ato pa, this one is A cross in the direction of B, meaning the direction is towards the board. So, this is a vector. A vector nga ang direction niya pasulod sa board, and the magnitude of that vector is equal to the area of the parallelogram formed by A and B. Nakuha? The two vectors will eventually form a parallelogram. And that area of that parallelogram is given by the cross product of the two vectors that form it. Okay? So, in fact, it will now be, in the more advanced applications of the cross product, you will meet there the area vector, which is a way to define a surface. Where is the surface facing? Right? To define it, you just need to cross two vectors on the surface, and you are sure that the vector does not lie on the surface, right? If this is the surface here, you have a vector in the surface dire, you just cross, you have a vector that is actually either paan siya sa area, and you can now have the notion of area n hat vector, right? Gauss's law is written in terms of this, right? Electromagnetism is written in terms of that n hat area vector. What's an area vector? Area is not actually a vector. It doesn't make sense it quite doesn't make sense to have a notion of an area vector. But if we think of an area as something that is facing where? Because if this is a surface here, if this is like a board here, the board is clearly facing here, not dito. So I can have now the area of the board, the area vector sa board is a vector kung asa ang directionally face ang area. Okay? Like, if I have this curved surface here, and I would name the face, I would actually require the face to be kaning dire, then it's facing dito. Or I can, if naadiri ang face, then the area would be here. I can define it in any way I want. So that the area, okay, anyway, that's a more advanced application of the cross product. Okay? So, by the way, just a concrete example, no? What's the cross product? Example. Okay, an example here. Suppose that A is equal to 2. I don't write the units. Pero di na lang ko isulat ang units, 0, 1, negative 2. What is A cross B? This is I, J, K, 2, negative 1, 2, 0, 1, negative 2. And this is I times negative 1 times negative 2 is 2 minus 2 times 1 is 2, right? Plus, sorry, minus j times, sakto ba? 1, 2. Minus j times, this is 2 minus, sorry, this is negative 4 minus 0. Right? Minus 0. That's negative 4 minus 0 plus k hat times 2 minus 0. So, 2. So, this is 0i. 4j, this is now 4j plus 2k hat. Okay? How about B cross A? To verify this one. How about B cross A? Okay? B cross A now is I, J, K, 2, negative, it's 0, 1, negative, 2, and 2, negative, 1, 2. So this is I times, this is 2 minus 2, right? Minus J times 0, 0 minus negative 4. So 4 na, plus 4, right? Plus k hat times, that is 0 minus 2, right? So this is clearly negative 4j minus 2k, which is just a negative of this vector. We have verified that property, right? A cross B is negative B cross A, which is just equal to negative of 4j plus 2k, right? That is a negative vector. You have to change the sign of the So this is just negative A cross B. This is not a proof that A cross B equals negative B cross A, no? It's not a proof. It's just an illustration, no? It's not a proof, but an illustration. Okay? Now, how about the magnitude? Well, it's difficult to use the magnitude definition if our vector is in Cartesian. But it is easy. The definition, the definition A, magnitude of A cross B is equal to the magnitude of A times the magnitude of B cosine of, sine theta AB is what? Can be easily used if we have the vector given in terms of the polar or modified polar, right? What was our modified polar ganiha? Example. Okay, example for this one. Our modified polar is sa itong ganiha? This is 2 meters. What was that? 30 degrees northwest. 60 to. 60 to siya. And then our B was 5 meters, 30 degrees northwest, right? It's a standard. Okay, what is now A cross B? A cross B is, this is now easy to use. This is now easy to use atong kuan ganiha. Remember that usa tong A dot B ganiha? What was A dot B? Our A dot B was tung dire negative. Okay, ato lang usbo no. A dot B was, this is 2 meters 5 meters cosine of what? 30 degrees, right? The angle between them. No, tama? Okay, I'd like to kuha siya, no? This is A. This is A. And this one is B, right? This is 30 degrees and this is 60 degrees, right? So clearly that is 30. Tama? So this was 10. This was 5 square root of 3 meters squared, right? This one, on the other hand, this is 2 meters times 5 meters times sine of 30 degrees, which is, this is 10 meters squared times sine of 30 is just 1/2. So this is 5 meter squared. Okay? Now, what's the direction of this? Of course, if the vector is dire, A cross B, since the vector is on the board, two vectors lies on the surface of the board alone, so A cross B is outside, kaning dire, no? Clearly, A cross B, naa siya dire, it's directed here. That's the direction. So we can think of this as, we can think of A cross B, in fact, if this is I, J, K, dire, we can just think of this A cross B as 5 meters squared K hat. We can just do that. Okay? If this is a special case, no? If A, X, and B are on this, if this is the I, J, and this is the K. Nakuha? But if A and B lies on any arbitrary surface, now of course, this is no longer this. It will have a different form. Nakuha? No? So, maybe I'll just prefer not to write that one. Okay? So this is, okay, another remarks. Look at this. This is the maximum and the minimum. Okay, remark. Usa na ta?
Mark 10.
No, we have 10 ganiha. 11, 12. Remark 12. Using this definition, the maximum occurs when sign is 0. Sa ato pa, A cross B is maximum, the cross product, the magnitude of the cross product, okay, is maximum when theta AB equals 90 degrees or pi over 2, right? But, again, we have now A cross B equals 0, or this is minimum, the magnitude, or even the vector. Either the vector or the magnitude. Anao na lang nato. Either the vector itself or the magnitude is 0, no? If theta AB equals 0. That means, okay, this would imply here that the cross product of two parallel vectors is 0. Now, this is now a way to know if the two vectors are parallel. Diba? The dot product gave us a way to know, to verify, to check whether two vectors are perpendicular. Now, the cross product, on the other hand, would give us a way to determine, a way to verify if the two vectors are parallel. They are parallel when the cross product is 0, right? It's clear by this definition because when this is parallel, the theta is what? Either 0 or 180 degrees or pi. Sine of 0 or pi is 0. So, the cross product of two parallel vectors is 0. No? So, it's easy to check that. So, again, some sort of a review. Ang cross product, if this is vector A and this is vector B, the cross product is the area of this parallelogram formed by A and B. Nakuha? That is the area. That is the magnitude of the cross product is that area there. Okay? Let's go back to vector addition. In vector addition, we can easily add a vector, right? We can easily find the resultant vector of any number of vectors. Just add all the x components, add all the y, right? It's easy. But suppose we have these two vectors. What is A plus B? Now, this is now a problem. Because A plus B, we could not add these two, one here. Add ni mo ni, that would be A plus B. No, that's wrong. Okay? But what we do, what we can do is, since this is, say, okay, let's go back to the principle of vectors. There are many ways to name a vector. Okay? This is as I've said in the beginning, the naming of a vector depends on the coordinate system. But that doesn't change, the coordinate system doesn't change the vector, only its name. It doesn't change its identity. What's the identity? For example, this is the point, this point here. If I'm going to put a coordinate system here, and that point, dira siya, and name it in terms of AX and AY, okay? Then this would be given by AX, AY. But if I'm going to put a Cartesian, a polar, dire, then I'm going to name this in terms of this magnitude of A plus that 1. Nakuha? So, or even pwede ko magbutang og dire, coordinate system. But putting a coordinate system anywhere doesn't actually change the point. This is the same point, no? So, okay, by the way, even if however I'm going to define this, the point doesn't change. Only the way of naming that point. For example, it's just like word. Let's say bread. In English, it's bread. In Bisaya, it's pan. In Tagalog, it's tinapay. It has a different name. It has a different accent. And even it will be spoken differently, in different accent by whoever speaks that one, no? Tinapay. I don't know, how would an American pronounce a tinapay? No? Or lechon. Yeah, tinapay. Pagigutom ng noon ko. So, pan. But we are actually referring to the same food. It doesn't change the food. Pan is tinapay. So, the same with one here. So, that means that we can, since we could not add vectors here, all we need is convert the vector, rename the vector. We are now in the idea of renaming the vectors into Cartesian. Nakuha? Renaming vectors. So what I'm going to do is that rename this vector, translate this vector in the Cartesian vector, and translate this vector into the Cartesian vector, and we can now add the two vectors together in the Cartesian form. And then translate the sum back to the original. That's what you are going to do. And how do we translate? How do we translate a vector now? If this vector is given by AX and AY, clearly the polar form of A is, we have to first to get the magnitude of A, right? Kani. So what's the magnitude of A? No? For any Cartesian vector, we can actually convert it into a polar vector. Okay? By what? Taking the magnitude of A and taking this angle. By the way, what is this angle? This is AX and this is AY. No? So, the magnitude of A, take the magnitude of A, which is AX squared plus AY squared, and take the angle theta dira, theta as the tangent inverse of what? Since we have an agreement to only name the to only take the direction on such that the rotation is coming from either the positive or the negative x-axis, then this will be tangent inverse of AY over AX. And then direction dire, northeast. No? So for example, the vector 2, 1. Okay, this is negative 1, 2 na lang. Okay? So, suppose this is vector A. So, my A, magnitude of A now would be what? This is 1 squared plus 2 squared, square root. So, this is square root of 5. Right? How about the direction? Theta A, theta now would be equal to tangent inverse of what? What is Y? This would be 2 over negative 1. Just take the absolute value because we now Okay, first, in order to write this, we have to take we have to illustrate, you have to draw this one. What's negative 1, 2? Negative 1, 2. So this is the vector. So since our agreement is to write the direction in terms of either in terms of the positive x or the positive, so sa ato pa, this will now be our direction. What would that be? That would be north, west, right? North of west. So theta now, this is now north of west because we are here. Okay, by the way, what's tangent inverse of 2? 63.4 degrees. So sa ato pa, this vector A now can also be written as what? Square root of 5 units, 63.4 degrees northwest. This vector and that vector are exactly the same. Approximately, because we are approximating the nagkwanta dira. Okay, now it's easier to convert a modified polar vector into Cartesian is much easier actually. For example, this one. Okay. 2 meters. Kanina siya, no? So, 2. So, sa ato pa, this one is AX, right? And this one is AY. And this is what? This is 60 degrees, right? 60 degrees. Tama? So, in that case, so katowa, right? Sine, okay. So, AX now will be, if this is the angle, what is AX? AX will be the adjacent. This is the opposite and this is the hypotenuse, right? So katowa, opposite, this is now AX is equal to, okay, this magnitude here, which is this, the magnitude of A times cosine of the angle. Let's call just theta A. Nakuha? Because we are actually in the, I'm saying, we are naming the vectors daalang ta diri sa negative. I mean, in terms of the rotation from the x-axis. So, this is what? 2 meters times what? Cosine of 60 degrees. Pila ni siya? 1 meter, right? Cosine of 60 is 1/2. How about B? How about AY? AY is the magnitude of A times sine theta A, which is 2 meters times sine of 60 degrees. This is square root of 3 over 2. So this is square root of 3 meters. Sine of 60 is square root of 3 over 2. Okay, to make this clear, 2 meters times square root of 3 over 2. So you get that one. Okay? How about BX? B is, where is B? 30 degree. Mo yung B, right? This is 30 degrees, right? So, this one is, the hypotenuse now is 5 meters. So, this is BX and this is BY. So, same gihapon, BX is the magnitude of B times cosine B, right? The good thing about naming, this is actually why we have I made that agreement with you. Because naming a vector, naming a modified polar vector such that the rotation is in either of the axes, positive or negative, means that the x component is always the cosine and the y component is always the sine. Nakuha ninyo? That's you don't need to think cosine ba ni or sine asa ang hypotenuse. If we make the rotation such that it's on the positive, it's coming from the x-axis, no, the nearest x-axis, then the rotation, the x will always be the cosine and the y will always be the sine. So, and the angle defined by that will always be the tangent of y over x. Okay, so this is the magnitude of B, which is 5 meters times cosine of 30. Cosine of 30 degrees, this is 5 meters times cosine of 30 is square root of 3 over 2. So this is 5 halves square root of 3 meters, right? 5 halves square root of 3 meters. How about B, Y? So this is magnitude of B times sine of theta. B, this is 5 meters, sine of 30 degrees. This is, sine of 30 is 1/2. So this is just 5 over 2 meters. So sa ato pa, we now have our vector A and vector B in Cartesian form. In Cartesian form, A is, okay, what is A? This is given by 1, I'll just omit the units, okay, to make it shorter. 1, what do you know? Square root of 3. How about my B? Will be give, okay, sorry. I should, this is in the, what quadrant are we? We are in the second quadrant, okay? Sorry. So take note of that. Since we are in the second quadrant, this will be negative and this will be positive. No, negative x and positive y. How about B? You will have, what's bx? This is negative 5 over 2 square root of 3 and then positive 5 over 2. Now the resultant vector is just A plus B, no? A plus B, which is equal to the resultant vector R, is, you add this one. That's negative 1 minus 5 over square root of 3. That would be negative 7 over 2 square root of 3. Okay? To avoid decimals, okay? Anyway, you have calculator to calculate this. Nakuha? 5 halves, okay, square root of 3 plus 5 halves, no? So this would be my vector. Okay? Now, okay, this is positive, right? And this is negative. So which quadrant does R lies? This is because this is negative and this is positive, right? Which quadrant? Still in quadrant 2. Okay? Still in quadrant 2, right? So, I can ask, this is Rx, no? And this is my Rx, and this is my Ry. So that I can ask, you have to make an illustration of this. Rx, now which one is larger? No, you can just Rx and Ry, no? Ano na to? This will be my angle, right? Theta. Now, if this is my angle here, my direction will be northwest. By the way, what's the magnitude of R? The magnitude of R is what? Negative 7 over 2 square root of 3 squared plus square root of 3 plus 5 over 2 squared square root. Kindly do this in your calculator. So, according to your calculator, this is 7.39 meters, no, units. How about angle? Theta now would be what? Theta is tangent inverse of y over x because, okay, so this is square root of 3 plus 5 over 2 over, just with the negative because we now know our direction. 7 over 2 square root of 3. This is what? So, shift tangent 34.9 degrees. Now, notice that this is 30, our resultant vector is somewhere here, right? Which is expected. No? In the middle sa ilaha. No, in fact, if this was A here, our resultant vector is dire, no? Kaya kung ato na siyang anaon, right? We can actually predict somehow na siya dira, right? So this is our vector and it's 7 points larger. So that our resultant vector would be, I can now write my R as what? R now would be, okay, 7.39 meters, 34.9 degrees northwest. This is the sum of that. This is equal to A plus B, no? This is how we add. So basically, even if you have many vectors on the x, y, and the z, I mean, if you have vectors in the modified polar, many vectors, what to do? Okay, steps in I'll just write the steps. How to add polar vectors, or we'll just use news vectors, no? North, east, west, south vectors. One is, first step is convert each vector to Cartesian. No? Convert each vector to Cartesian. Because our definition of addition is only in the Cartesian. Okay? And the step 2, okay, S1, S2, add all the converted, okay, converted vectors using the definition in Cartesian, no? Using the definition, right? Okay? This is actually the resultant vector. And then S3 is, of course, you now have the sum. Convert the resultant vector, which is the sum, resultant vector back to the original CS, coordinate system, right? Well, if your coordinate system is already in the Cartesian, you don't need to convert it, no? Okay, not naman sa Cartesian. It's easy to add vectors in the Cartesian. So, advantage and disadvantages. What's the advantage of Cartesian vector? Cartesian coordinate system? We can add vectors there, no? We have, okay, we have Cartesian, masabay ko andre, Cartesian, no? Cartesian and versus news or polar. News or modified polar. Modified polar. News coordinate system. Advantage o iyahang disadvantage. Okay? What's the advantage of Cartesian? Easy to add. Right? It's easy to add. Easy to locate. Well, pareho naman siguro sila duha. Maybe it's easy to add. Components are already given. Are given. Now, in fact, another term for Cartesian vectors are component form of the vector. Or in some introductory books, they call this the components. Find the x component and the y component. What we are actually doing is converting the vector into Cartesian vector there. The advantage of the modified polar form is that the magnitude is already given. Magnitude is given. No? And of course, you can find the angle. An angle is given based on ano. Easy to find. Okay, this is a magnitude. Easy to find the angle between two vectors. Okay? And the advantage of this becomes the disadvantage of the Cartesian. Here is magnitude is yet to be solved. And another disadvantage is hard to find the angle between any two vectors, no? Between any two vectors. Okay? Here, between any two vectors. Easy to find the angle. So that's why we use katong ano. The disadvantage of the news coordinate system is that, of course, the advantage here. Hard to add. No? And of course, it's hard to calculate A cross B. The vector form, not the magnitude. This is, okay? Well, it's really easy ang magnitude of A cross B, right? It's easy. But A cross B as a vector, remember that this is the vector form. Medyo, no? Okay, I'll write C to make it clear that this is the vector form of the cross product. It is hard to calculate that in terms of the modified loose coordinate system. And by the way, here, it will be easy to calculate, no? You see, no, these are just some of the advantages. So that's why we need to convert vectors into Cartesian. Any vector, anyway, there are many other ways to write a vector. Okay, we just discussed two types, no, the modified polar and the Cartesian. In any, we have to add the vectors in terms of the Cartesian. So we need to convert, no? We need to have some conversion. Okay, so I think that sums up today.